Okay, this is the video lesson for Algebra 1 4.1, using graphs to relate to quantities. So graphs compare, well, in this case, just two things. And so in a graph, if we are using words to draw the graph, a key phrase would be like rise, speed up, or increase. This means the line or curve is going to go up from left to right. This is talking about an increase. A decrease, or the word fall, slow down, would be a line. Let me just draw these right. This would be an increase, this would be a decrease from left to right going down, and from left to right. And then a constant would just be a horizontal line, right? Nothing's changing as you go left to right. And then a sudden decrease to 0 would be a vertical line. Okay, so let's look at this first example. It says, this graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Well, here you can see this is comparing volume and time. So the variables here would be volume and time. And, oh, oops, sorry, this actually should be here. Those variables, okay. And then describe how the variables are related at various points on the graph. So here we can see, and if we look back up here, this part of the graph here, right, this is an increase. So from here, the volume is going up. And that's the same here and here and here, right? So if you think about air in a balloon, right, as it's blowing up, right, so someone's actively blowing the balloon on all these green spots. But these flat parts here, right, that is flat is constant. So you can think about if someone's blowing up a balloon, right, they're blowing it up, I should make that in green. They're blowing it up, they take a break, but time still goes on, right? They're blowing it up, so the volume increases, they take a break. They're blowing it up, they take a breath. Blowing it up, and then what happens here, this is a vertical line, sudden decrease to 0. What happens to the ball, a balloon? It pops, right? So here's where it pops. And that's an instantaneous pop, right? So the volume was here and now it goes to 0 so fast, that's a vertical line. Okay, so that is kind of a simple example of really what you're looking at here are going up, going down, staying flat, or instantly going down. Okay, so, oops, next page. Look at this here. This is when you're going to think through A and B. Right? This is a, what are the variables in each graph? So write the variables and then describe how the variables are related at the various points on the graph. So each time the shape of the graph changes, say what's going to happen there. In this case, right, these are all the same, so you can say the same thing what you think is happening. And this title says board length. This is the length of a board. And then this is June's cell phone cost, right? This is cost and the minutes of the call. So think through this just like we just did the last one. Press pause and then check back for the solution. Okay, so for this first one, we're talking about board length. The variables are board length versus time. So this is the length of the board as time goes on. So here we have two different types of lines. Here we have a constant line and a vertical or sudden decrease. So for the constant, right, the board length is going to stay the same here. So as time goes on, the board length is staying the same in all these green spots, right? But these vertical sudden decrease, if this is the board length, that would be maybe someone is cutting it down at that moment. So the board length stays this and then someone cuts it. Now the board length is here, then someone cuts some more off. Then the board length stays here, then it cuts up more off, and then it stays the same. So that's what's going on, that's what this graph is telling us is going on with the board, or the length of the board. This one is the June cell phone cost. So in June, right, the cost is here. This is minutes of calls. So here we have a constant. So the cost is going to stay the same. There's some amount of cost. So there's some just, he's already, or the person has used this one. So I guess for the month, right, no matter what minutes of the call, the cost stays the same. So for the month, there's probably some kind of cost where there's a, for your first 10 minutes or 3 hours or something of calls is a certain cost, right? But once you hit that cost, right, it's going to start increasing and going up. So perhaps this cell phone plan is, it's, you know, $30 for the first 60 minutes in that month. And then once you hit 60 minutes, you start paying by the per minute and it goes up. Maybe it's like, you know, 20 cents a minute. So this is here is where it changes. So the cost stays constant for the month, and then it starts to increase. I think I wrote at the end of the call, but it's till the end of the month, because this is a monthly plan. Okay, so that's how we're going to start thinking about these. You just want to look at the different shapes of the pieces. Okay, so another one, these are called discrete graphs, where they're just dots because there are certain times, right? In these cases, there's just, the time just goes on and we can fill in, there's always something happening. The length of the board, there's always a length at every single time. In these examples, they're discrete because there isn't anything in between. In this case, let's see this example, it'll make more sense. A band allows fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. But you can't have a half of a download, right? So that's why in between, right, or a day, in this case this is downloads in day, you can't have a half of a download and you can't have a half of a day. So this is just days and downloads. So these are just at integers. Which graph could represent the data in this table? So we can see here, when we're looking at a table and a graph, this is going to be your x-axis. So you can see this is day, 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 day. So there are 4 days, 1, 2, 3, 4. So each one of these dots represents each day. And then the downloads, you can see around 350. Then the next day it's 1,000. But then the next day it goes up to 3,000, over 3,000. And the next day it goes to 10,000. So this is increasing, right? So it's increasing. It's going up. As the days go up, the downloads go up. So it should be increasing. So this one is decreasing. So this one's out. And then what you also want to look at is how much it's increasing. You can see here, right? If we're just looking at this, this is increasing this much, this much, this much. This is a constant increase. It's going up by the same every day. So let's see, this is about 700-ish it's going up by. This is going up by almost 2,400, right? And this is going up by almost 7,000. So as you can see, this is not constant. To day 2, it increases 700, but the next day, that increase is more than double, and then this one is about double. So this one can't be true because this is saying it increases constantly. If we look at this one, right, this is a increase. This is a slightly smaller increase, and this is a really tiny increase. So the increases are getting smaller. These increases are actually getting bigger. So this can't be it. And so this is going to be the one, and you'll see here, right, this is an increase, this is an even bigger increase, and this is an even bigger increase. So this could represent our 700, our 2,400, and our 7,000. Right, you can see like 350, 1,000, 3,500, 10,000. Okay, so this is our graph. So here's one for you to try. This says that this table shows the amount of sunscreen left in a can based on the number of times sunscreen has been used, right? So number of uses is discrete. There's only, right, you can either have no uses, 1 use, 2 use, 3 use, right? And then the amount of sunscreen left in the can. So think about what this means and then think about which one of these graphs is the one. Press pause, think about it, make a guess, and then check back for the solution. Okay, and hopefully here you notice it's going down by 0.2 of an ounce each time they use it, so it's going to be a constant decrease. The decreases are all the same. And this one you can see this creates a line, so it's going to be A. This one would have been a small decrease, a bigger decrease, an even bigger decrease. So these would be using more sunscreen each time. And this one is, oh, I was wrong. Look at that. Look at that. I just guessed really fast. That's okay. Oh, look at that. All right, so we learn a lot when we all make mistakes. Look, this is also constant, but look how tiny that is. And that makes more sense because, right, this is saying by the 4th use, the bottle's empty. Is that true? Or sorry, by the 3rd use. No, there's still 4.4, so it's barely going down a little. So this is the answer, not this. Look at that. You make mistakes when you rush through, as I just learned, as you're learning from me. Okay, so C is the answer here. Right? And remember, this is 0, so we can see here. The 3rd use did not get us down to 0. Okay, moving on. So here, this is just getting a little bit more involved. This says a rocket model rises quickly, then it slows to a stop. So it's rising quickly, it's slowing to a stop. Right? This is, height versus time. Okay, so rising quickly, then it's rising still but slower. It's slowing to a stop as its fuel burns out. It begins to fall quickly. Right here, it's falling quickly, until the parachute opens, and then they fall slowly back to Earth. What sketch of a graph could represent the height of the rocket during this flight? Well, look at that. I just already put it. And I think it makes more sense if we talk about it as we're going through this, right? And this is see, when it's talking about this as falls slowly, it's constantly falling. This is falling faster, falling constantly, slowly, right? Rising quickly, slower, stops, falls quickly, parachute opens, falls constantly. So a line is going to be a constant fall. Okay? Last one for you to try, and you're going to actually draw your own graph for this. Suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height off the ground might change over time? Label each section. All right, this is a little challenging. See if you can figure this out yourself and then check back for the solution. Okay, so this one, obviously these answers are all going to vary, but the key here is looking at, right, how's your height changing over time? So the variables are height versus time. So if you draw a swing, right, the swing is already a little bit off the ground, so it's never going to be at 0. So when you start, you're going to be just a little bit off at 0. That's what this red line is, and this is where you stop, right? But as you start to swing, you swing a little bit higher, and then you go back to where you started, and then you swing even higher than that, and you go back to where you started, and then you get even higher than that, and then you get back to where you started, right? Forwards, back. This is probably forwards, back, backwards, back, forwards, back, backwards, back, and then you stop. So it's probably longer than this, right? You're going to be swinging longer, so, and it's probably more gradual. You probably have 2 of the same height, and then as you get higher. But this is kind of just showing you the general height of a swing, right? You're always going to be going back to the height of the ground because the swing has to pass here. You go up, high, higher, slower, stop. All right, that's it. It's just, this lesson is just kind of getting us started reading graphs and using graphs. Okay, so it's time for practice. Enjoy.